In this video, we are going to take a look at how to solve mathematical problems involving significant figures. So you saw all the rules of how to determine how many significant figures a number has, but why do you need to do that? Well, ultimately, you're going to be asked to take measured values and do some type of mathematical operations with those. Your answer must be reported to the correct amount of uncertainty, or the correct number of significant figures. So we want to look at the rules of how to determine how many significant figures an answer should have when you multiply, divide, add, or subtract measured values. So let me give you a quick example of what I mean. Let's say we wanted to measure the diameter of this coin using the ruler. Okay, our rule tells us we would set it up correctly and we'd look at our ruler, which is marked every 1 centimeter. If our ruler is marked every 1 centimeter, then we can estimate one more decimal place past that. So our diameter would be 2.5 centimeters, maybe 2.4, maybe 2.6, but it would be 2.5 centimeters with the 0.5 having some uncertainty associated with it. Now let's say you took the diameter of the coin and you wanted to determine the radius of that coin. Well, to determine the radius, you take the diameter and divide it by exactly 2. So the radius would be 2.5 centimeters divided by 2. Now if you punch that into your calculator will give you 1.25. Well, that raises a bit of a problem. Our measurement was only certain to the tenths place. The ones place we know, and the tenths place we know with some certainty. But when we divide it by 2, our calculator tells us that now we have a number that is to the hundredths place. So do you see what happened here, or the issue? Our calculator gives us 1.25, and if we write that down as our answer, then we're saying that we know this answer with certainty to the hundredths place, but the actual measurement only gave us certainty to the tenths place. So would the correct answer be 1.25, or would we round it to 1.3 centimeters? Well, we need to look at the rules on how to perform calculations involving measured values. Okay, so let's take a look at the rules for multiplication division and how to determine the number of sig figs in an answer when we multiply or divide something. Let's say we were performing this operation here. We were calculating miles per gallon, and your vehicle went 278 miles and it took 11.70 gallons. Well, our first number on top, the miles, that has 3 significant figures, and the number on bottom has 4 sig figs. So when we divide to get our miles per gallon, we get 23.76068,376. This is what the number that my calculator spit out. Of course, the units are miles per gallon. Now, how many sig figs should our answer have? Well, because we divided, the rule for multiplication division is our answer can't have any more sig figs than the number with the fewest sig figs that was involved in our operation. So since this top number had 3, the bottom number had 4, our answer can't have any more than 3. So another way to say that is the answer can't be any more certain than the least certain number. This is certain to only to 3 sig figs. This is certain to 4 sig figs. So our answer can only be certain to 3 sig figs. So what we would need to do is round this number in order to express it as 3 sig figs. So we would round this to 23.8 miles per gallon, and all of these will be dropped. We'll talk about the rules for rounding in more detail in just a minute, but suffice to say, our answer should only have 3 sig figs. Now the rule for multiplication division is very different than the rule for addition and subtraction. When we add or subtract, we look at the number of significant decimal places. So let's say we wanted to add these two numbers. Our top number here is significant to 2 decimal places, and the bottom number is significant to 5 decimal places. So we're not looking at all the sig figs, we're just looking at the significant decimal places. So if we add these numbers together, we get 3.19315. So how many sig figs should our answer have? Well, our top one had 2 decimal places, the bottom had 5, and our rule tells us that our answer can only have can't have any more decimal places than the number with the fewest decimal places that was involved in the addition or subtraction. So our 5 would not be significant, our 1 would not be significant, our 3 would not be significant. The first significant figure here is 8, and so because this has 2 decimal places, our answer would be rounded to 3.19. So our answer would have only 2 decimal places as well. So please be aware the difference in rules between multiplication, division, and addition, subtraction. So let's mention just a little bit more about rounding before we move on and work some problems, adding and subtracting, multiplying and dividing. There are lots of different rules for how to round a number correctly. We're going with a very simple rule here. Basically, if you have a 0 to 4, you round down. So you drop all the digits after the last significant figure and leave the significant figure alone. You add any insignificant zeros to keep the value the same. If the number is 5 to 9, then we round up. We drop the digits after the last significant digit and increase the last significant by 1. We add, of course, if you need to add any zeros to keep the value the same, you can do that. So let's practice rounding. If you would, round these numbers so that they have 3 significant figures. Okay? So pause the video and give those a shot. Okay. So our first number, we're asked to round it to 3 significant figures. So here we have a 5, 6, and 7. So we want to round that, and so we want to drop all the numbers after the 7. Here we have a 3, so we would not round the 7 up, we would leave it as a 7. So we would drop the 3, 2, 4 and everything here, but as our rules tell us, we have to add some zeros here to keep the place the same. So we'd have to replace the 3, 2, and 4 with zeros, because 567,000 is not the same as 567. So we have to add those zeros, and these are insignificant zeros. So again, we just have 3 sig figs here. Here, we're asked to round this to 3 sig figs, so 4, 6, 7. We want to keep these, and we want to drop everything else. The first number we're dropping here is a 5, so we would round up. Here we'd round up to 4, 6, 8, and we would drop the 502. We don't have to add zeros here because those zeros would be significant if we added these trailing zeros. So our answer would be 0.00468. And finally, we want to round this number to 3 sig figs. So the 4, 7, 9 would be significant. We're dropping the 5, 2, 3, and 4. The 5 here, of course, tells us that we need to round this up. So we would round this up to 480. So this would be 4,800,000 would be the answer. Now, this is a little tricky here. How do we indicate that this 0, because we want 3 significant figures, so how do we indicate that this 0 is significant? Well, there's a couple of ways. One way is just to underline it. If we underline that 0, that's a way of indicating that that's significant. But more commonly, we can write this number in scientific notation. 4.80 times 10 to the 6. Again, all of these numbers that you see in scientific notation are significant. So that would be how we would round those correctly to 3 sig figs. So let's work a few more problems here. And here we want to practice some calculations, multiplying and dividing and rounding our number to the correct number of sig figs. So pause the video, perform these operations. Again, these are measured values, so assume these all to be measured values and have significant figures. And round your answer to the correct number of sig figs. Pause the video and give that a shot. So let's take a look at the first problem. If we multiply these and divide them in our calculator, we should get something like this as our answer. Now, how many sig figs should that answer have? Well, this number has 3, 2, 4, and 2 sig figs. And our rule for multiplication division, our answer should have the same number of sig figs as the number with the fewest sig figs that we used in our operation. So we would round our answer to 2 sig figs. So we want 0.067, and this is a 5, so we'd round that up to 0.068. Again, these zeros in front are not significant. Be sure you remember your rules for determining sig figs. And here, we multiply and divide these numbers. We should get about 1.51863. How many sig figs should it have? Well, we have to look back at these numbers. This has 4, 3, and 6. Our least certain number had 3 sig figs, so our answer can only have 3 sig figs as well. 1.518, we're dropping the 8, which is 5 or greater, so we'd round that up to a 2. So 1.52 would be our final answer. Okay, now let's practice a little bit more. Here we have some addition and subtraction problems. Perform these operations, assume these are measured values, and report your answer to the correct number of significant figures. Pause the video and give it a shot. Okay, so here we're adding and subtracting, so we want to look at the decimal places, not the total sig figs. Okay, so when we add all these and subtract them, we should get 124.867. Now that's not our final answer. We have to round it. This number has 3 decimal places. This has 1 decimal place. This has 2 decimal places. Again, don't look at the total sig figs, just the significant decimal places. So our answer can only be significant to 1 decimal place. So 124.8. The tenths place is our last significant decimal place. Since we're dropping the 6, we would round that up to a 9. So 124.9 would be our final answer. And on this one, if we subtract these numbers, should get a negative 8.664. How many sig figs should it have? Well, this has 3 decimal places, this has 3, and this has 2 decimal places. So this one's significant to the hundredths. So my answer can only be significant to the hundredths decimal place. Negative 8.66, this is a 4, so we don't round up. So we just drop it and get negative 8.66. So finally, let's take a look at a problem that involves multiple different types of operations. So you're going to be asked throughout your chemistry course, your chemistry career, to perform mathematical problems that involve both multiplication, division, and addition, subtraction, all in one problem. Which rule do you follow? Well, in general, what you want to do is perform each operation. Don't round the number, but keep track of how many sig figs the answer has. And then at the very end of the problem, you round. So when you perform large problems involving multiple steps, the golden rule is you don't round until the very, very end. And as you perform the operations, we have to do them in the correct order. If you recall from algebra, I don't know, I learned it like this. Please excuse my dear Aunt Sally, parentheses first, then exponents, multiplication, division, addition, subtraction. So let's take a look at the problem here, and let me kind of walk you through it and show you what I'm talking about. You're asked to calculate the weight per square foot, and you're given this problem. Okay. So first thing we want to do is perform the operations in parentheses. So we're going to add these two together and multiply these two. Okay, so we're going to add the numbers on top, and that's going to give us 35.5 pounds. And we're going to multiply the numbers on the bottom, and that's going to give us 2.45 feet squared. Okay, our units should be feet times feet gives us feet squared. Now here's what I'm talking about. If I add these two numbers, the 20.5 and the 15, if I add them, this is significant to the tenths place, and this is significant only to the ones place. So my answer should be significant only to the ones place. Remember the rules for addition and subtraction. So the answer to this problem by itself would be 36 pounds. But we don't want to round the number until the end. We don't want to round because every time we round, we introduce error. So if I add 20.5 pounds and 15 pounds, I get 35.5 pounds. The answer is significant to the ones place. In other words, it has only 2 sig figs, but I'm going to keep the 35.5, and you see I've underlined the 5. I've underlined it just to indicate that that is the last significant figure. So this number here only has 2 sig figs. The 35.5 has only 2 sig figs, but I've written all of them out. Down here, 2.45 times 1.00 feet gives me 2.45 feet squared. This has 3 sig figs. The 1.00 has 3 sig figs, so my answer has 3 sig figs. So I've underlined the 5, the last significant number here. Now I need to divide. If I divide 35.5 by 2.45, my calculator spits out this big number here, but of course that's not our final answer. 14.489, etc., pounds per feet squared. How many sig figs should it have? Well, this number, even though I have 3 digits here, this number has only 2 sig figs. This number here, the 2.45, has 3 sig figs. So since we did our division problem last, we're dividing something with 2 sig figs by something with 3. Our answer can only be certain to 2 sig figs. So I would round this to 14 pounds per feet squared. Because this is a 4, I don't round up. I just leave the 4 as it is. So the final answer here would be 14 pounds per feet squared. Okay, so this is a very important rule to remember. Don't round until the end. Keep track of the sig figs after each operation. Okay, so let's give you a little practice. Take a look at this problem and solve the problem and round your final answer to the correct number of significant figures. Remember to follow the rules we just discussed. So pause the video and give this a problem a try. Okay, so let's take a look at our answer here. First thing I want to do is perform the operations that are in parentheses. So if I add these two numbers together, I get 46.98. Now, I don't round this number, but look, this number here is significant to 2 decimal places. This number here, 1.2, is significant to 1 decimal place. So my answer is significant only to 1 decimal place for that operation. So I get 46.98. I underline the 9, indicating that that's significant, but I don't round it yet. And the units here are centimeters. I perform the operation in parentheses over here, multiplying these two numbers. The first number has 1, 2, 3, 4, 5 sig figs, and the second number has 1, 2, 3, 4 sig figs. Okay, so again, be sure to review your rules for sig figs if you have any questions. So we're multiplying something with 5 times something with 4 sig figs. So I write out the entire number here, but my answer is only significant to 4 sig figs, the answer for this operation. So I have 1, 2, 3, 4. So I've underlined the 8 to indicate that that's my last significant number. The units here, grams times grams, gives me grams squared. So now I need to divide 46.98 centimeters divided by 0.354806 grams squared. I divide those, and I get, my calculator gives me this big number here. I need to round it to the correct amount of certainty, or the correct sig figs. my first number has 3 sig figs, my second number has 1, 2, 3, 4 sig figs. So my answer can only have 3 because that's the number with the fewer sig figs. So I would round this because we have a 4 here. I would leave it as is, and I would have 132 centimeters per gram squared would be my final answer. Okay. So practice some more of these problems from your text. Be sure you're very comfortable working problems involving sig figs and multiple operations using measured values.